Today we're going to take a look at solving exponential equations using logs. So as a reminder, the old type of exponential equations that we've been able to solve up until now are the ones that are like, let's say we had 8 to the 3x equals 16 squared. So this is the old type that we were able to solve. We got a common base here, and so we looked at this and said they're both powers of 2. And so we said that this is 2 cubed is 8 to the 3x. 2 to the 4th is 16 squared. And then we said, okay, our rule of exponents we multiply. So this is 2 to the 9x. This is 2 to the 8th. So if we solve this, we said 9x equals 8. So x equals 8/9. So what we're going to do is we're going to look at today is what do we do if you can't find a common base? So let's take a look at a problem here. Let's say we have 10 to the x equals 93. So 10 and 93 definitely don't have a common base. So what we're going to do is we're going to use this idea of logs. So to each side here, I'm going to add a log. So I'm going to say log of 10 to the x equals log of 93. And so you'll notice here, like I use the common log with base 10, but I could have a common, if I want to do log base 3 of, that'd be fine, and log base 3 on each side. But just like algebra where we can add, subtract, multiply, or divide something to each side, I'll log each side. Use our rule of exponents that we can bring the exponent out in front. And then to solve for x, I would just divide each side by the log of 10. So x equals the log of 93 divided by 10. And then this is one where we could use Desmos to solve. So we have, and you can just type in log if you're doing it on a computer. So the log of 93 divided by the log of 10. If I round to the nearest hundredth, 1.97. And when I think about that, that makes sense because 10 squared is 100 and 1.97 is a little bit under 2. So let's take a look at another one here. So let's say we have 3.8 equals 1.1 to the power of x minus 5. So again, can't have a common base, so I'm going to log each side. And again, it's the common log, so just base 10. Log 1.1 to the power of x minus 5. So I'm going to bring that exponent out in front. But since there's more than one term in the exponent, I'm going to put that in parentheses. And now let's see. Well, we could distribute, or I could say, okay, I'm going to divide by log of 1.1. So now I have, so the log of 3.8 divided by the log of 1.1. 3.8, 1.1, so 14.01. And then I could add 5. So we have 19.01 equals x. And we could double check this. I could go back here and say 1.1 to the power of 19.01 minus 5. And we could see we got 3.8. And yeah, that's what we wanted it to be, was 3.8. All right, so let's take a look at, we're going to take a look at two more here. What if I had 44 times 3 to the x equals 11? So this one's a little different because we have a number before our base and our exponent. So before we log each side, we have to get the base and exponent by itself. So divide by 44, divide by 44. So we have 3 to the x equals 11 over 44. And now we can add that log because that base and exponent's by itself. So log of 3 to the x equals the log of 11 over 44. Bring that exponent out in front. So x log 3 equals the log of 11 over 44. Divide by log 3, divide by log 3. So x equals, go back to Desmos here, the log of 11 divided by 44 divided by log 3. So negative 1.26. And again, I can double check this by saying 44 times 3 to the power of negative 1.26, 9.87. Oops, 26. 9.87, and that is about 11. So we have the right answer there. So the very last one we're going to take a look at together is, let's say we have 11 e to the x equals 1. So again, we have to get that base by itself. So e to the x is our base, and remembering e is that number there. So not another variable, e is that number, so divided by 11. So we have e to the x equals 1 over 11. Now I'm going to log each side. So the log e to the x, log of 1 over 11. Bring that exponent out in front. So x log e, log of 1 over 11, divided by log e, divided by log e. And I already forgot what I had there. Got to go back. So the log of 1 over 11 divided by log, and I can just type in the letter E, and we have negative 2.397. So that would round up to negative 2.40. And again, let's double check this. So we have 11 times e to the power of negative 2.40, 0.997, which is really close to 1.